Hello, today we are going to make a presentation about our project, which is gesture-based messaging platform. Let's start. Firstly, I want to talk about what problem we are trying to solve. All of us know that most of simple messaging apps are based on same simple actions such as typing by touching, or some apps let us to send message by talking, use voice recognition. We think that those apps are not so efficient for multitasking and accessibility for some cases. Our solution is simply send and get message by using our hand gestures. We think it is fast and easy way to message with someone comparing to traditional methods. And our general scope is users, chats, messages, etc. Also, we use scalable database and backend for our needs to create this project idea. Our team structure is like you see in this slide. Arda is responsible for system architecture and data strategy. Yiğit is responsible for ER modeling and data population, and I am responsible for database queries and operations of them. So why we use a scalable database for our project? To safely store our user info and their messages, to present relationships between users, chats, and groups, to access history and activity trackings, to scale our data as user grows. And next section will be about our data architecture and how we implement this project.
Hi everyone, so I'll be walking you through our data architecture. First of all, we created an ER diagram for our database design, of course, and we designed a clean, normalized relational model following third normal form standards. Our proposal actually listed 8 tables, but here we actually show 6 core entities and 2 many-to-many relationships actually discovered through our database design, resolved with associative tables later. I can talk about our entities. Strong entities are user and chat. These are entities that actually form the backbone of the identity and conversation layers and can exist independently. That's why they are strong. And there are weak entities: message, file, notification, and status. These are strictly dependent on their parents. For example, a file cannot exist without a message. If the message is deleted, the file must be deleted too, which we enforced via cascade delete. There are key relationships like is contact, is member, sends, contains, has file, receives, and posts. Which you can see is member and is contact are man-to-man relationships. We resolved these with contacts table for is contact and group members table for is member relationship here. The double line diamonds are identifying relationships 1 to n. These are posts, has file, receives, contains, as you can see. Data population strategy actually, for the project requirements, we avoided manual data entry, and data in our system was created via requests sent to the Flask API actually. Users were created with post register endpoint, messages, post messages sent endpoint, groups are post groups create. The important part is that these are not inserting the scripts manually, so the API actually was the only gateway. So all of our logic was ensured that they were triggered correctly every time. Here you can see an example of populated data on the right with the SQL code on the left.
Now let's move beyond theory and see how gesture chat performs in practice. The interface you see on the screen is fully synchronized with the database architecture we developed on the backend. I can type only using my right hand, as you see, and I can send my message, or like just I can put space or delete them. Also, I can navigate through the message on the sidebar by using my left hand. This is our RESTful API interface, the gateway through which our system interacts with the outside world. Following the project requirements, these endpoints were written entirely using raw SQL queries without the use of any ORMs or autocode generators. Let's verify if the message I just sent reached the database. Like we can see that there are messages in the database which was sent. Beyond simple data retrieval, we can process analytical data that is critical for investors and managers. That activity executes the most complex query of the project. Behind the scenes, this query performs join across the user's message and group tables and calculates user interactions using group by, and provides us with the ranked report of the most active users. And this allows us to identify system bottlenecks or trends in real time. This endpoint, we can see which user has it joined and last seen and total message informations. Now let's move on to our data management strategy, where we focus on the technical robustness and efficiency of our system. A great application needs a solid foundation. For our data management strategy, we chose PostgreSQL to handle our structured metadata securely. But our key architectural decision was to use the coupled storage approach. Instead of slowing down the database by storing heavy media files directly inside it, we only store their file pointers. This keeps our database lightweight and lightning fast. This strategy is crucial for our future growth. It ensures that our app maintains high performance and scalability.
So I want to mention our CRUD operations simply. Create is used for registration of a user and sending messages. Read is used for reading chat history with sender info and secure user authentication. Update is used for changes in profile and their status, and also updating message states. And our deletion operations are soft delete messages and blocking or removing contacts. So basically our key strengths of this project are clean and normalized relational design and real-world scalable architecture, gesture-first interaction model, database-enforced integrity and privacy using safe blocking logic, complex nested SQL queries for privacy and analytics. You can see some samples below. In conclusion, a future-ready messaging platform built on a solid data foundation. Thank you.